Constant law. This law deals with constant functions. Since y is always equal to k, it doesn't matter what x approaches. Example 1. Limit of 8 as x approaches to 6 is equal to 8. So, using the constant law, since it doesn't matter what the x approaches, the answer is 8. Identity law. This law deals with the function y equals x. Since y and x are equal, whatever value x approaches, y will have to approach the same value. Example 2. Limit of x as x approaches to 4 is equals 4. Using the identity law, since x approaches to 4, the answer is 4. Addition law. This simply means when we take the limit of an addition, we can just take the limit of each term individually, then add the results. Example 3. The limit of the quantity of x plus 5 as x approaches to negative 7. First, we're going to use the addition law. We have to separate the terms x and 5. Then, we're going to apply identity law for the first term, so it's negative 7, and constant law for the second term, so it's 5. Then, negative 7 plus 5 is equal to negative 2. That's the final answer.
Subtraction law. Essentially the same as the addition law, but for subtraction. Work with each term separately and subtract the results. For example, the limit of x minus 5 as x approaches to 2. First, we're going to apply the subtraction law, wherein we have to find the limit of the terms separately. So, it would be limit of x as x approaches to 2 minus limit of 5 as x approaches to 2. Then, we're going to apply the identity law for the first term, so it would be 2. Then constant law for the second term, so it would be 5. 2 minus 5 is equal to negative 3. Constant coefficient law. If your function has a coefficient, you can take the limit of the function first and then multiply by the coefficient. For example, the limit of 8x as x approaches to 3. First, we're going to apply the constant coefficient law, wherein we have to isolate the coefficient first. So, it would be 8 limit of x as x approaches to 3. Then, we're going to apply the identity law for the limit of x as x approaches to 3, so it would be 3. Then, 3 multiplied by the coefficient 8 is equal to 24. Multiplication law. If the function involves the product of two or more factors, you can just take the limit of each factor, then multiply the results together. For example, the limit of x multiplied by 5 as x approaches to 2. First, we're going to apply the multiplication law, wherein we have to get the limits of the terms separately. So it would be limit of x as x approaches to 2 multiplied to limit of 5 as x approaches to 2. Then, we're going to apply the identity law for the first term, so it would be 2. Then the constant law for the second term, so it would be 5. 2 multiplied by 5 is equal to 10. Power law. When taking limits with exponents, you can take the limit of the function first, and then apply the exponent. But you have to be careful. If the exponent is negative, then the limit of the function cannot be 0. For example, the limit of the quantity of x plus 1 raised to 3 as x approaches to 4. First, we're going to apply the power law, wherein you can take the limit of the function first and then apply the exponent. After that, we have to do the addition law for the x plus 1. So it would be the quantity of limit of x as x approaches to 4 plus limit of 1 as x approaches to 4 raised to 3. Then, we're going to apply the identity law for the first term for the limit of x as x approaches to 4, so it would be 4. Then the constant law for the limit of 1 as x approaches to 4, so it would be 1. So, it would be 4 plus 1 equal to 5, then raised to the exponent 3, so the final answer would be 125.
the division law. It tells us we can simplify, find the limit of the numerator and the denominator separately, as long as we don't get 0 in the denominator. For example, limit of 2x over x minus 4 as x approaches 12. First, we're going to use the division law wherein we're going to find the limits separately. Then, we apply the constant coefficient law for the numerator, so you'll put 2 before the limit. After that, we're going to use the subtraction law for the denominator. Lastly, apply the identity and constant laws, so it will be 2 multiplied by 12 over 12 minus 4. It will be 24 over 8, and the answer would be 3.
Root law. For root functions, we can find the limit of the inside function first and then apply the root. We have to be careful that we don't end up taking a square root of a negative number. For example, the limit of the square root of x plus 18 as x approaches to negative 2. First, we're going to apply the root law wherein we have to find the limit of the inside function first. So, it would be the square root of limit of x plus 18 as x approaches to negative 2. Then, we're going to apply the addition law wherein we have to find the limit of x plus 18 separately. So, it would be the square root of limit of x as x approaches to negative 2 plus limit of 18 as x approaches to negative 2. After that, we're going to apply the identity law for the first term and the constant law for the second term. So, it would be the square root of negative 2 plus 18. Negative 2 plus 18 is equal to 16. The square root of 16 is 4. The final answer is 4. Composition law. Suppose limit of g of x as x approaches to a is equal where m is a constant. Also, suppose f is continuous at m. For example, the limit of sine of x as x approaches to pi. First, we're going to apply the composition law, so it would be sine of limit of x as x approaches to pi. Then, we're going to apply the identity law for the limit of x as x approaches to pi, so the answer will be pi. Sine multiplied by pi is equal to 0.